Okay, let's come back to our class. Okay, for this week, for this hour, we'll talk about the text-based analysis with Orange. Okay, so for Orange provides some interesting models and tools help us to analyze text-based data. For example, articles, paragraphs, sentence, words, something like that. Okay, so make sure you have your Orange ready. Okay, as again, here are some add-ons. Okay, you need to click Orange 3 text. Okay, make sure you have those features in your program. Okay, so that is it. Okay, so what is data analysis? Okay, basically they help us to deal with some corpus. Corpus 中文就是文库哈，文集啦哈。Okay, so we'll introduce several different features right here. Okay, so let's first take a look at this text. Okay, text mining. Okay, originally we drag the file right here, right? So we can see the file informations by using the data table. Okay, like this. Okay, so that is the housing data, right? But when we analyze text, okay, we don't use file. Okay, so here's the corpus right here. Corpus right here. So corpus. So of course there is a viewer which was here. Okay, so since we don't have numeric data in text mining, okay, so we have another new Corpus Viewer. So we connect it together. Okay, see for corpus. Okay, we see that. Okay, we have several different corpus file. Okay, right here. Unfortunately, we have only 5 different preload corpus right here. Of course, you can use your own corpus. Okay, so for example, we use the first one. Okay, it's Tales. 这是格林童话嘛 ？Okay, Grim Tales. Okay, so there are several different information right here, and we can simply just click corpus viewer. Okay, so as we can see that here are 44 documents, 44 tales. Okay, so each of them they have a title. So title is right here. So when you click different documents, we say articles. Okay, there are several different features right here, including what is the ATU topic right here, which means what is this tales about. Okay, so that's a tale about magic. So tales of magic. Okay, and its title, a tale about the boy who went for to learn what fear was. Okay, that is a tale, and there's a very simple abstraction. It's only one sentence, and here's the content, which is the corpus itself, which is the document itself. So basically, it has very long document. Okay, so of course there are several. For example, Hansel, Gretel. Okay, magic. Its title is very simple, abstract, and its content. So the data format is a little different. Okay, usually in previous analysis, we use numeric data, right? Calculated data, but in text mining, okay, data looks like this. Okay, so we have 44 different articles. Okay, and what is our target? Okay, so for example, we can use a model to analyze the information right here, abstract, title, and content, to do a classification, to classify, okay, what kind of topic this document belongs to. For example, here is the tales of magic. Okay, animal tales. What else? Okay, at least we have 2 different categories which describe the topics. So we use the ATU topic as our target. Okay, so that is the corpus. Okay, so when we analyzed a corpus, okay, what is the first thing we like to do? is this one usually. Okay, it's called word cloud. Okay, so put it right here, connected the corpus to the word cloud. Okay, the word cloud will create an image. Okay, an image right here like this. Okay, so it simply just count how many words in the corpus and what is the frequency, which is the weights right here of these 44 documents. Okay, so as we can see, the most popular word used in this corpus is this word, the, 4,346 times, and some punctuation is right here. Okay, so basically, however, such kind of information is useless because as we can see that for the first 10, we say words, they're just some very general normal words, right? And they do not they're just normal words. Okay, so usually when we analyze a corpus, okay, we can insert a widget right here, which is this one, pre-processed text, and also it's right, I think it's right here, right? It's right here. Okay, it will remove some normal words. So let's take a look at this one. Okay, we have several different pre-processes can be done right here. Okay, the first one is transformation. Usually, okay, we select this one, lowercase, which means we do not differentiate words with capital, alphabetic, or words. Okay, so we transform all the words in a document to lowercase. Okay, that is very useful. Okay, and sometimes we check those button, those checkbox. Okay, remove accent. So for example, how do you spell realize? REALISEOIZE. Okay, they will have a database to make sure these two words will be represented by only one words. Okay, remove accent. Okay, if your document is download from the network, from the website, okay, maybe your document is represented as HTML, which is a format of web page. Okay, so you can parse HTML. They will remove all the HTML tags and useless and style. Okay, so only words, sentence, okay, paragraph will be left in your corpus. Okay, they will remove all those HTML tags and JavaScript and all those non-relevant words in the document. Okay, and of course you can remove URLs if you want to do so. Okay, that is transformation. The second one is called tokenization. Okay, because we input a document, okay, and this document has several paragraphs, and for each paragraph there were several sentences. In each sentence there were several different words. So how do we tokenize those words? Basically they are English, right? Because the document those are basically English. So usually you can partition this word by a regular expression, which is right here, which means I would like to partition those sentences by using punctuations, white space, and something like that. Okay, so click this one, choose this one is good enough, okay, to tokenize all the words in a single document. So that is good enough. Okay, so let's take a look at this one. Okay, the default one, which is filtering. Okay, as I said, the words such as he, she, the, to, is, are, something like that is a little bit useless when we analyze a document, because they are necessary and normal words that you have to use in a sentence, but usually it does not have very semantic for meanings. So those words are called stop words. Okay, so it has a predefined database that has defined several stop words which you would like to filter out those words when you analyze the document. Okay, of course you can prepare another new document. Okay, this document, another document. This document has all the stop words you don't want to analyze. You want to filter those stop words out. You can define your stop words. Okay, so you can select your database right here. But we use the default one is good enough. Okay, so here are some filtering functions and mechanism. What kind of words you like to filter out? So we like to filter out stop words, and of course you can filter out some interesting things like most frequent tokens. That means there are some tokens, okay, they are not in the stop word list, but they are used quite often. So every document has these spatial tokens, which might be a very some very many of these words. If you would like to filter out those things, you can simply just click this one, and they will select, okay, what kind of words will be filter out. Okay, something like that. For example, you can simply just click it. So the first 100 most frequent tokens, except the stop word, okay, will be filtered out because you don't want to use them. But usually we set the filtering like this is good enough. Okay, it's good enough. Okay, we'll talk about those preprocessors later. Okay, so after that, you can see that we have two different word cloud. Okay, the original one, which is like this. Okay, and you can see that there's some irrelevant word. Okay, there's stop words which we don't want. Okay, so after you apply those things, pre-processing. Okay, we can see that those words are much more meaningful because punctuations, white space, capital words, those words will be removed. Okay. However, there's some, of course, there's some words like of course, you can define, for example, you don't want the word sad. You want its word to be filtered out. You can use your own stop word list and put the set in this stop word list, and you can filter it out. Okay. For example, the set has we can simply just click this one. Okay, with most frequency token. Okay, the first 10. Okay, so we close it and we try it again. Okay, you can see that the first 10, only the first 10 will be left. So we should use the opposite one, this one. Okay, the document frequency means we remove the data of the words which is higher than 90% and less than 10% of occurrence of frequency. Okay, that the most, and that means we keep the first 100, but it is not. It keeps the most frequency token, not remove them. Oh, sorry, I just missed them. If you want to remove the most frequency, you should use document frequency because it only kept from 10% the words that use in 10% between 90%. Okay, so that is so this word cloud will be much better. Okay, will be a little bit much better than this one. Okay, so usually we don't use this one. We use the preprocessed one. Okay, so that is the preprocessing things. Okay, so after that, let's take a look at we can still use the data table, okay, to observe the corpus after we do preprocessing. So it looks like this. Of course, we have 44 documents, so we have 44 rows right here, and here's our target, which is our topic. Okay, it is either Tales of Magic or Animal Tales, and here is the title right here. Is the title. Of course, they are all text. They are not numeric data, abstract and content, something like that. Okay, so that is the original data. But if you connect the data table after the word count, okay, so like this. Sorry, it should be word count. Word count. Okay, and you can see that how many words are count. Okay, so that is it. So the next things, but usually you just output those the things. Okay, we don't. It's not that useful. Okay, so that is. So next one is bag of words. It's right here. Those are simply just help you to know what kind of words has been used in your articles, right? So how do we transform the text-based data to numeric data? So that is the first mechanism called bag of words. So we connect it to here, and we connect a data table right here. Okay, so let's take a look at this one. The information will be converted to more richful. Okay, those things are original. Sorry, these columns. Okay, topics, title, abstract, content, something like that. That just the old things. Okay, after bag of word. Okay, a new column will be right here. Okay, however, this column is a little bit different, a little bit strange. Okay, it records. Okay, those words, for example, right? Sorry. Okay, as we mentioned before, we have a word count right here, right? We have a word count right here, right? So basically, how many word counts? How many words are listed here, right here? Okay, and you can see that 3,719 words are counted in our corpus. Okay, in our corpus. If you want to remove all those words that only exist in our corpus once, okay, you can select, as I mentioned before, you can select the preprocessing. Maybe you can click this one. Okay, after that, you can see that the word count changes. Right? In this case, only right here, only 907 words will be considered. Okay, because the word with too many frequency count will be removed. The word with too less count will be removed. And when we want to use some numeric data to describe an original document, okay, as we mentioned before, if there is a feature that its variance or standard deviation, its variance or standard deviation is very high or very low, that means this feature is useless, because everyone has this feature. For example, if there is a feature which is the color of eyes, and for example, in our classroom, all the students, their eye color are all black, so the variance will be the standard deviation, the variance will be very, very low. That means this information, which means all the students' eyes color is black, is meaningless. They cannot help us to distinguish different students. So usually we will apply this preprocessing right here. We want to remove the words which appear in all documents, and we like to remove some words that only appear once in a document because they have very, very low, we say, variance. And information, which means feature, which has very low reference, is useless for analyzing, for our analysis. Okay, that is. Also, after that, you can see that it changes. Okay, we only have 900 words. Okay, so the data table right here, it is a list. Okay, it is a list. It for each rows. Okay, in this column, it has 907 words, and this corresponding frequency count will be listed right here. So in this document, able occurs. This word, okay, occurs once, afraid once, ago once, as which I don't know what it means, 7 times, blah blah blah, and etc. And would like to use the information in this list to describe to describe the article numerically. So the next one is still right here. Okay, let's take a look at which one? I think regression is good enough. Okay, then we do a classification. Okay, so we do a classification like logistic regression. Okay, so logistic regression, we use the information that in that array, which this array. Okay, so basically you have a new table which has 907 columns, and each column has this number right here. So that is okay. So the next thing is let's do evaluation first, which is okay. The same thing. Okay, we apply two models. For example, regression models right here. We use SVM model right here. So basically, it's the same. Okay, we connect the model right here. That is the input data right here. So basically, the logistic regression and SVM, they will use the features provided by bag of words, which is the 907 columns, and each columns in each cell is the occurrence frequency of the word that used in the document. Okay, they will use such kind of information to do logistic regression and SVM. The target, as I mentioned before, the target is the topic, right? Because the topic is okay, so that is, then we can put it right here because it's a classification problem, right? So we can see that we have two different models right here, and the classification rate for logistic regression. Okay, among those 907 features, okay, the classification rate of the topic is 90.9%. SVM is not that good, 84.1%. Okay, so configure matrix looks like this. Okay, for the logistic regression, okay, we have 44 documents, right? So this cell means there are 18 documents. They are actually animal tails, and the predict model by logistic regression, 18 of them are classified as animal tails, and 4 of the documents are misclassified. Okay, so SVM is not that good because 7 documents are not classified into correct topics. Okay, however, we can still see some information about the misclassified ones. So let's take a look at Corpus. Let's take a look at the table. We can simply just still connect the data right here. So we can see that. Where's the result here? Where is the result? Classification results. Sorry, not right here. It should be connected to right here. Okay, and we can see that we have 44 documents, right? So here is the result. Okay, we have 2 models right here. So which is the result of logistic regression, the result of SVM. Okay, here is the probability that so here's the we can see that there are several documents that are misclassified. So let's take a look which one. These 2, right? Actually, for example, let's take Okay, I think that's good enough. Okay, for this example, okay, originally it should be animal tails because I think that it describes something about bear. Okay, however, in our SVM it says it is a magic tail because the word used in this document. Okay, and we do some machine learning, right? So machine learning, the SVM says, okay, the word used in this the widow worm and the bear is much like it's much more like a tale of magic. Okay, so but however there's some I mean there's some tales. Okay, their characters are animals. They can talk, they can do something interesting, but they are classified into magic tales. That because the word they use is more like magic tale. Maybe that is because the bear can talk. Okay, so it's really depend on what is the word the writer choose to use. Okay, so that is how we use back of words technique to convert the text into a very large feature table, which has 907 features. Again, and for each the data in this feature table is the word count in each document. Okay, so that is. So what else we can do for text mining? So next things we can do is clustering. Okay, these two pink model, they are model, right? They are models, so they are supervised learning. But however, we can still do something about unsupervised learning after we have big words. So let's remove these things to right here. Okay, so since we have the table, right, 907 features, so we can do very simple distance metrics. As what we, I would like to remind you how do we do hierarchical clustering. So maybe there is a file and we have iris data right here, and of course iris data. So in supervised learning, we can use the 4 features right here. Okay, so there is a vector. There's a vector which has 4 items, four items, and they describe the flower data, right? And we can perform hierarchical clustering after we use this, right? After we calculate the distance metrics. So basically, we can do such kind of things, right? Hierarchical clustering. Maybe we can take some time to review hierarchical clustering because I think it's very important. So let's take a look at our iPad, my iPad. Okay, so that's it. So let's review some clustering, especially hierarchical clustering. So okay, basically when we describe the data, you can simply just like for example, I have 2 dimension. Okay, so maybe there's a data right here called A, B, C, okay, D. Sorry. Sorry again. Okay. We have several different data right here. Okay, when we do hierarchical clustering, okay, we have to predefine a distance function. So that because we have only 2 dimensions right here, so we can simply just use Euclidean distance. Okay, so the first step is we cluster the data point. Why it disappeared? Okay, I think there's something wrong with the there's something wrong with the okay, basically you choose the 2 data point which has the closest with the smallest distance. So that would be A and B, right? So you do a cluster right here, right? And then next you choose the other data point which has smaller distance, which is D and E. It's right here. Okay, then select the next one. Okay, the next one maybe, okay, maybe, I say maybe, that is C and AB. So you cluster C and AB, and then you cluster all the rest of data. Okay, so usually we present it as a hierarchical clustering. So usually it should look like this: A and B, they have the smallest distance, and then C, and then E and D. Okay, the distance between E and D is larger than A and B, so it should be a little bit higher than A and B, and then we cluster them together. So basically, they are those are the same thing. Okay, this is the same thing when we talk about hierarchical clustering and space. Okay, so basically you can use all your data, okay, to calculate the distance and use the distance to do such kind of hierarchical clustering. Okay, so you can see that is the result. Okay, but how do we do hierarchical clustering by using the result backward? It's the same. So we simply just connect a hierarchical clustering after the distance function. Okay, so we can see that for word, okay, there are several different parameters that can describe the distance linkage between different things. Okay, usually we use WARD. Okay, use this one. Okay, so we can see that if we use the same technique to connect, we say cluster, to cluster the different document based on the 907 features. Okay, we use the 907 features to create a space, right? Has 907 dimensions, and for each dot in this space is a document, and we measure the distance between each data point, which is that distance. Okay, so we cluster them together by using hierarchical clustering. So the result will be like this. Okay, so basically there are some tails. Okay, so basically I think that is good enough to. That is good enough to. I think it should be right here. Here. Okay, and you have to design a distance. Okay, in your hierarchical clustering result, and for the groups, for the cluster, which their distance is lower than certain value, okay, they will be clustered. So in this example, okay, maybe we set the value right here. Okay, so we can see that there are 3 different classes: C1, C2, and C9, and there are some other tails that cannot be merged to other cluster. But however, we can see that the document in cluster 2, they are all tails of magics. That means the words they used, they are much more similar with each other. That means in that 907 dimensions, the data point, they are close to each other. Okay, and of course, there are another cluster right here. I think there's another cluster right here. The word they use is a little different from the word they used right here. So they have two different clusters right here, right? This one and this one. But they all falls into the class of Tales of Magic. Okay. However, we can see that for this cluster, okay, or for this cluster, okay, we can see C1 and C2. C1, they are all animal tales, which is good enough. But for C2, some of them are Tale of Magic, some of them are animal tales. So let's take a look at, for example, this one, maybe this one. So we can see that this one. Okay. We simply just take this one. Okay. This one. Okay. So we can connect a data table right here. After the hierarchical clustering, it will output the selected data. So it's right here. We say that most of them are animal tales, but part of the the document in this cluster, they are magical still, because the word they are using are more like animal tales. So let's take a look at this table. Okay. I don't know if you are good, if you know much about those tales. Maybe you can tell me the queen bee is the word it used is more like animal tales, not like magic tales. Okay, maybe you can make this such kind of judgment. Okay, so that is the result. Okay, you can use prediction, or you can use clustering to help us to analyze the document data, the text-based data. Okay, so I think the next one would be prediction. Okay, prediction. So the corpus we used here is Grimm Tales, right? So we can we can do prediction, right? So let's take a let's create a model right here. Okay, here's a model, logic regression. Okay, so it can create a model, okay, by using the backup words. Okay, and we can use this model with different corpus right here. For example, the original training corpus is Grimm, right? So we use another similar things, Anderson. Anderson 童话, huh? Anderson right here. So we can use this model. Sorry. Sorry. Not this. Okay. First we have this one, and for Anderson, we do a prediction. So prediction is right here. So we use a linear regression as a model to learn how Grimm corpus and its topics, okay, by using backup words. And then we use this corpus, which is Anderson, to help us to do prediction. Okay, so the result would be, okay, we connect the result right here. Okay, that means, okay, Anderson is a very small corpus, right? So it's right here. It has only 3 documents in the Anderson tales, okay, in our corpus. Okay, so the first one, the prediction result by logical regression. It says, okay, it's 98% of probability is more like animal tales. Okay, for the second one, it's a 99.99% is magic tale, and this one is that 91% is animal tales. Okay, so it's the same. We can still use prediction when we apply text-based data, because after backup word, they are no longer text. They will become a 907 feature table, and since it is a table, it is numeric data, we can use it for all the other widget models, predictions, text and score, confusion metric, and set all the other widgets that we taught before to analyze text-based data. Okay, so that is prediction. So what else we can do? let's see. Okay, semantic analysis. But it may take some time. Okay. Semantic analysis means there's a database in the network. You can download the database from the internet. Okay. It has several different English words, and it will has a score after this English word, which indicate this word, the meaning of this word is positive or negative sentimentally. So for example, good is a nice word, and some for example frustration, which means the sentiment 对它情感 is not good. So there's a database. So here is the sentimental analysis. So let's remove this one to here. So we can connect the result backward to the sentiment analysis, and the result will be very interesting. That you can see. Okay, we have a different method of semantic analysis. Okay, so we can still connect the data table after the semantic analysis. It says, okay, where's the result? Sentimental result. Where's the result? Data corpus, sentimental analysis. Where is it? Just a moment. Corpus. Click this one. English, multi-language, English. Oops, sorry. Corpus. We use a smaller corpus, okay? I think it should be yes, language multi-sentiment is okay. The result is right here. So it is connected after a corpus, not deck of words, okay? Because it only deals with they don't deal with the numbers. It only deals with the words they used. So the result is right here. So that means this article, okay? This article is right here, right? This article sounds positive or negative or neutral. We have three different values right here. Basically, the idea of this kind of analysis just simply map all the words and the original corpus, okay? And they will look up a database, okay? The database says, okay, this word, okay, is negative. For example, minus 0.1, okay? The next word they use, for example, happy, is a positive word, which is plus 0.7, and they will do a weighted score. So the result will be like this. So as we can see that those tails are they most of the time they use neutral words, and the other time positive words are used quite often, and negative words are used not that quite often as positive word. However, as you can see that the ugly duckling right here, maybe this word ugly used quite often in the content. So the negative words, the score of negative words is a little bit higher than the other tails. Okay, so and of course you can choose another corpus and see the result of different. For example, we can see what is the best, what is the most, positive. what is the most positive tells that where is it here? This one, okay. The Elvis and the Shoemaker, okay, that is the most positive tells in this corpus because it is a very high positive score, okay, and which is the most negative token sparrow. So that's the result, okay. So that is sentimental things, okay. So let's take a look what else we can do. Okay, so that is another one. So let's take a look at the document embedding. Okay, so where's the corpus? Okay, where's the corpus number 3? Okay, never mind. Right here. Okay, so let's take a look at the corpus we use. Still, we use the gram corpus. Okay, so here is the document embedding, which means there's another way to transform those text-based data to numeric data. Okay, of course, back of words are one of the way to convert the original text data to numeric data. However, there are some other ways to do such kind of things. Okay, so you can simply just connect this one to here. So this document, of course, there are several different algorithms that can convert the text to numeric data. However, there are some very well-known algorithms that we use them quite often. So you can simply just apply those algorithms, which is document embedding. It takes some time because it reads all the words and all the documents, and it will try to find a best representation, which is a numeric data. Okay, so let's take a look what is the result of such kind of embedding. Embedding means convert the original data to another new linear space. Okay, we have described what is linear space before, right? So you simply just take a look at this one, and you can see that the original data is right here. However, you can see that. Do you see that? Okay, there is a 300 dimensions, and those values are purely numeric data. Okay, and we use these 300 dimensions and those numbers to represent the content right here. Okay, what kind of algorithm they use? Actually, I don't know. Maybe we should check it in the Orange's official website. But actually, it can do the same thing as back of words. But I don't know what is the algorithm they use because they don't know. I don't know how they do not show what is the algorithm they used right here. So basically, if you want to do the same thing, such as right here, you want to do hierarchical clustering, do the same thing. Okay, you can connect it to the distance function, and then hierarchical clustering, and then you can see that again we have a very nice clustering result. Okay, which is right here. Okay, however, I do not recommend to use this this kind of unknown models. Okay, but it is one of the way to convert data. Okay, so I think that's it. Okay, I think that is most of the things we might use in the document, or we say word text mining. So let's go back to our website right here. So you can see that here is a data set. Okay, here is a corpus. Okay, the corpus right here is spam mail data, which means, okay, you can see that right here. Okay, we don't have to in this data set, okay, it has several different columns. For example, there are 48 attributes. Attributes means data, okay? They are numbers, okay? They are numbers from 0 to 100. They present the percentage of words in the email that match words. That means this data set already gives us pre-processed data set, okay? There are several emails, spam mails in the data set. And it's in this email data set, okay? They count specific words. There are 48 specific words, and their corresponding counts right here. Okay, of course there are certain things, and at the last there is a column called nominal. Okay, it is either 1 or 0, which indicate it is a spam mail, or it is a spam mail, or it is not a spam mail. So basically, you can collect a lot of email, no matter if it is a spam mail or it is a normal mail. Okay, you can create such kind of table manually. Okay, you select some words which is very useful for us to do such kind of prediction. Okay, you can design your own table to describe the data. Okay, or you can simply just use the tools right here, backup words. Okay, oh sorry, this one. Backup words, or you simply just use an unknown model which can give you a 300 dimension vectors to represent email. Okay, and then you can apply any supervised learning or unsupervised learning data to help you to cluster spam mail or normal mail, or help you to do classification to classify spam mail or normal mail. So this week we have homework. Okay, we will give you a lot of emails, but we will not tell you which one is spam mail and which one is spam mail, or which one is normal mail. And you have to design some mechanism. For example, you can do some pre-processing, you can do backup words, you can do document embedding, you can do anything you like to create your own feature tables. And then you use a model which is supervised or unsupervised, or a neural network which is good enough, and to do some kind of test, so that you can do a spam mail detector by neural network or by machine learning algorithms, which is the our next homework. Okay, so that is we stop right here, and let's come back at 15 after 11. Okay, we will talk about a very important thing, which is why neural network works and what is the visualized meanings of those neurons and hidden layers. Okay, so let's take a break.